Find the Hankel transform of f of x, which is equal to a square minus x square. X lies between 0 to a, and 0 x is greater than a. So n is equal to 0. So given f of x, which is equal to a square minus x square, and x lies between 0 to a, 0 x greater than a, n value equal to 0, that is equation number 1. We know Hankel transform of f of x, which is equal to integral 0 to infinite f of x into x into jn of px dx, which is equal to, we are going to split the integral into 2 according to the given function. So 0 to a first integral, right? In this case f of x value is given a square minus x square. Integral 0 to a square minus x square x into j of 0 px dx, because given n equal to 0, that is why we are replacing jn of px by j naught of px, j naught of px dx, plus integral a to infinite. So then x is greater than a, the value of f of x is 0, that is given. So integral a to infinite 0 into x into j naught of px dx. So we are using that one which is equal to integral 0 to a square into x j naught px dx. We are splitting into 2 again, the first integral. So first a square into x into j naught px dx, then minus integral 0 to a x square into x into j naught px dx. So a square is a constant, so take it outside the integral. A square integral 0 to a x into j naught px dx minus x square into x becomes x cube minus integral 0 to a x cube j naught px dx, that is equation number 2. Now we are going to find the value of first integral, that is a square integral 0 to a x into j naught px dx, that is equation number 3. We know that recurrence formula d by dx of x power n jn of x, which is equal to x power n jn minus 1 of x. So put n is equal to 1 and replace x by xp. So x by xp means dx becomes p into dx. So this recurrence formula becomes d by p into dx, because d by dx becomes p into dx. So d by p into dx x p power 1, because n is equal to 1, j 1 xp, which is equal to right hand side x into p power 1 j n minus 1, n is equal to 1 minus 1 into, so n minus 1 of xp. So p is a constant, so take it outside from the differentiation. So in the numerator you will get 1p, denominator already you are having 1p, so p by p d by dx of x j1 of xp, which is equal to px j0 of xp. P and p get cancelled, so d by dx of x j1 of xp, which is equal to px j0 of xp. Therefore x into j0 of xp, which is equal to, taking that p the other side of the equality, so 1 by p into d by dx of x into j1 of xp, that is equation number 4. From 3 and 4, so a square integral 0 to a x into j naught px into dx, which is equal to a square integral 0 to a replacing x j naught xp, which is equal to 1 by p d by dx of x j1 of px dx, from 4, right? Which is equal to, so 1 by p is a constant, so a square by p integral 0 to a derivative of x j1 of px, right? And d by dx of x into j1 of px becomes, we can write dx you can cancel, you can take it as it is, right? You can take like that, right? Derivative of x into j1 of px. So we know derivative of any function, integral derivative of any function is nothing but the function only. So integral d of x, what is the value? X only, right? Derivative of x only. Similarly Here we are having a square by p into derivative of something. Whatever the function, you will get the same function, because integral and derivative are reverse process, so both will get cancelled, right? So you will get x j1 of px, limit is 0 to a, right? So applying the upper limit, instead of x you put upper limit a, so a square by p, a j1 of ax, instead of x you are putting a, so pa, right, minus 0, right, lower limit. So therefore a square by a square integral 0 to a x j naught of px dx, which is equal to, so a square into a cube by p, j1 of pa, that is equation number 5. Now consider the next integral, 0 to a x cube j naught of px dx, that is equation number 6. From 4 and 6, integral 0 to a x cube j naught of px dx, which is equal to integral 0 to a x square. We are splitting x cube into two values, x square into x, because we need to replace x j naught px dx. From x j naught px value we know, that is from 4 we can replace easily, that is what we are splitting, x cube into x square into x. So x square into x j naught of px dx, that is equal to integral 0 to a x square. So replacing x j naught of px by 1 by p d by dx x j1 of xp dx. So that is equal to 1 by p integral 0 to a x square. So d by dx and dx get cancelled. You will get derivative of x into j1 of xp. So that is equal to 1 by p x square x j1 of xp minus 1 by p integral 0 to a x j1 of xp into derivative of x square. Now we are having two functions. One is x square in the previous step. One is x square. Another one is the derivative of x into j1 of xp, right? Two function. So we are using u dv formula, integral u dv, which is equal to uv minus integral v du. Here u, which is equal to x square, and v is x into j1 of xp, right? So 1 by p is common, so 1 by p into uv. U is x square, v is x j1 of xp, so uv, right, 0 to a, lower limit and upper limit, minus integral v du, minus 1 by p is common, integral 0 to a, v is nothing but x j1 of xp, and du, derivative of x square, right? So 1 by p x cube x square into x cube j1 of xp, limit is lower limit 0, upper limit a, minus 1 by p integral 0 to a x into j1 of xp, derivative of x square 2x dx, right? So that is equal to 1 by p, applying the upper limit a cube, right, j1 of ap, lower limit 0, right, minus 2 is a constant, so 2 by p integral 0 to a x square j1 of xp dx, that is equation number 7. We know that the recurrence formula, d by dx of x power n jn of x, which is equal to x power n jn minus 1 of x. So here we are taking n is equal to 2 and x is equal to xp. So x is equal to xp means taking derivative dx, which is equal to p dx. Therefore replacing d by dx becomes p dx, so 1 by p d by dx. So replacing x by xp and n by 2, right, replacing n by 2. So xp square j2 of px, which is equal to px square j1 of px, right? So p square by p d by dx of x square j2 of px, which is equal to p square into x square j1 of px. So 1 by p d by dx x square j2 of px, which is equal to x square into j1 of px. The previous step, p square in the left hand side and p square in the right hand side of the equality, so both will get cancelled, right? So we'll get the remaining, the 8th equation, right? So from 7 and 8, integral 0 to a x cube j naught of px dx, which is equal to 1 by p a cube j1 of ap minus 2 by p integral 0 to a 1 by p d by dx of x square j2 of px. So this becomes 1 by p a cube j1 of ap minus 2 by p square integral 0 to a. So dx in the numerator and dx in the denominator get cancelled. Derivative of x square j2 of px. So which is equal to 1 by p a cube j1 of ap minus, so derivative of x is x. So here instead of x you are having x square j2 of px. So you will get x square j2 of px, lower limit 0, upper limit a. So applying the limit, upper limit 1 by p a cube j1 of ap minus 2 by p square, applying upper limit a square j2 of ap. Applying when you are applying the lower limit 0, the term become 0, right? So 9th equation. So we know the recurrence formula again, 2n jn of x, which is equal to x into jn minus 1 of x plus jn plus 1 of x. So here we are replacing n by 1 and x by ap, right? So 2 j1 of ap, which is equal to ap j naught of ap plus j2 of ap. So j2 of ap, which is equal to 2 by ap j1 of ap minus j naught of ap, that is equation number 10. Now we are using this value in equation number 9, right? In 9 we are having j2 of ap, right? So we are going to replace. So from 9 and 10, integral 0 to a x cube of j naught of px dx, which is equal to 1 by p a cube j1 of ap minus 2 by p square a square into 2 by ap j1 of ap minus j naught of ap, right? We are using equation number 10 in 9. So that is why. So therefore integral 0 to a x cube j naught of px dx, which is equal to 1 by p a cube j1 of ap minus 4 by b cube a j1 of ap plus 2 by p square a square j naught of ap, that is equation number 11. So 2 from 2, 5 and 11 we will get Hankel transformation of f of x, which is equal to a square integral 0 to a x j naught of px dx minus integral 0 to a x cube j naught of px dx. So we know the values, right? For the first integral and second integral we are replacing a cube by p j1 of pa minus 1 by p a cube j1 of ap minus 4 by p cube a j1 of ap plus 2 by p square a square j naught of ap, that is a cube by p j1 of pa minus 1 by p a cube j1 of ap. So we are multiplying with minus, right? So minus into minus plus 4 by p cube a j1 of ap. So plus into minus minus 2 by p square a square j naught of ap. So h of f of x, which is equal to 4 by p cube, right? Because a cube by p j1 of pa, first term, minus the second term a cube by p 1 by p a cube j1 of p, both will get cancelled. So remaining 4 by p cube a j1 of ap minus 2 by p square into a square j naught of ap, which is the Hankel transform. Thanks.